Hello, ladies and gentlemen. Today we are going to conclude this series on biological intelligence. And to cap this series, the last talk that we have today is focusing on what is there for us to learn from all this knowledge that we have been unearthing in the previous episodes. Yeah. So there are two parts to this one. One is, of course, what technocrats and engineers can learn from biology side to innovate in their respective technology areas. And second part is what medicos and life sciences related people can explore and consider for research going further. So let me share my screen. So we are talking about innovative ideas for technocrat and out of the box suggestions for medico based on this series, the previous talks that we have. Of course, we are not revising or summarizing what we have learned, but what is the takeaway? We are focusing on some ideas, to be precise, six ideas for both the categories each. Yeah. So this is the 12th and last talk of this series, and but of course, as technocrat talks, we continue to bring other topics there, and also some topics related to this if we come across some requirement or there is some specific interesting things that we want to present. Yeah. So the first part is, as I said, what engineers can learn and innovate based on whatever knowledge that we have raked through. So the biggest thing to learn from biology side from engineers is that in biology, each hardware is a multifunctional entity. Okay. Whereas in engineering, each piece of hardware has a unique function and it is specific. Like structural member is a structural member, CPU is a CPU, memory is a memory, cable is a cable, right? In biological architecture, most of the hardware has more than one function. Now, this is food for innovation. You consider the bones. The bones are not just the structural frame, they also form the joints and kinematic linkages in limbs. They also store calcium. They also synthesize bone marrow, and they provide a flexi conduit for central nervous system, bundle of nerves that goes through the spine, and they have feature that they can maintain and repair themselves, and so on. And sometimes even the protective blood vessels and nerves pass through the hollow of the bone in the legs and all. Yeah. So the hardware has multiple functions. Just like this is just one illustration. All hardwares are like that in biology. So this is just I have given as an example for engineers to get inspired. Also considering the other kind of hardware, that is neuron. Uh, Neurons are not just analogous to a CPU in a computer, because they are also having memory within them. They are also doubling up for connecting cables with relaying stations in between, and they are directly interfacing with various IO devices or sensors or muscle end plate. Yeah. So they are having multiple functions if you consider them as hardware. Yeah. Whereas in case of engineering, in a car, because car everybody knows, battery is a battery and it's a dead weight and it sits on a bracket and you worry about its being overweight. Okay. But can we not design a battery so that it serves a part of a structural member also? I'm sure the kind of volumes we have in car, battery makers only will be too happy to customize the design of battery so that it can do some other function as well. Okay. As a matter of fact, in Tesla, the battery is forming the substructure, the floor of the car. Yeah, so that's an idea one can carry. It's not just for the battery, this is just an illustration that the same concept can be innovated, that whatever we do in engineering system better be multifunctional. And considering the second aspect, that something which can maintain itself in operating systems, of course, even in Windows, the later versions, we have features like self-maintaining features. If something gets corrupted, it repairs itself. Now that thing has already been inspired, and to some extent it has been implemented as well. Yeah. Also inspired from the bone. Bones keep on developing the worn out surfaces on the external side, the rubbing surfaces. So in engineering, there are some techniques where we can rebuild the worn out surfaces by leather cladding. I will show you some details of these processes. And also in bone joint, there is a bone joint carving function where some cells produce the surface and some cells dissolve it, osteoclast and osteoblast. And by way of movement, by way of osteoclasts working, they get shaped to complement each other, the two parts of the joint. Okay. So in engineering, we have something which is called as lapping technology. Okay, which also I will illustrate. It has been inspired from this one. Now this is the Tesla. The you can see the entire floor is having it's a battery. So it is serving as a structure of floor with the kind of strength and rigidity that it should have. And yes, it is also serving as a battery. So this is one idea which has been borrowed from biology, I would say, consciously or subconsciously. And this is the cladding function. So any surfaces which get worn out, with a laser one can throw powder and fuse it on the fly. So you can scan the whole surface and deposit another layer of the material. And after having deposited layer of material, one can have two mating, and in this case there are two gear kind of a things with teeth. To make the match the teeth profile, we put an abrasive slurry or a paste in between and run in these parts. Now that is called as lapping. So the surface geometry gets exactly suited with the counterpart. Okay. Now this is something similar to bone carving function, if you please. Yeah. It's not that engineers have not been getting inspired from biology, knowingly or unknowingly. They are doing some things which follow the same ideas. Okay. And that's the idea why I am broaching this subject, so that going further, more of such things we can see. Now, the second big plus point in biology is optimized energy and movements in everything. Optimization of energy and movement. And generally in biology, we don't have anything like motors or pumps or gearboxes or pulleys or clutches which are rotating as an engineering system. In engineering machines, we cannot imagine a machine without a pump, motor, gearbox, without something which are rotating shafts, rotating pulleys, rotating clutches, rotating gears. Yeah. And then also to break them, we use friction brakes, causing energy loss, friction, heating. In biological system, we have, for example, a cistern with the contractile walls. The tank can become smaller and bigger to either pump out the fluid or pump in the fluid. Okay. And with minimal energy, with minimal movement. Okay. So that's the example I'm giving. So in engineering also, if we can avoid some things rotating all the time, and instead we have some actuators which give energy on demand only. Yeah. Tailored energy on demand. Yeah. That would be great innovation. So if you see muscle, the muscle is nothing but a direct coupled linear actuation device. It's a kind of fiber to carry out controlled movement, and it can apply controlled force, tension. Yeah. So, and generally in biological system, we don't come across the use of high pressurized fluids like hydraulic oil, which getting heated and circulating, passing through small orifices and all. And we don't come across fluid flow getting used in a big way to do things in biology. It's a modest flow, so it is highly energy efficient. Yeah. So in hydraulics nowadays, we come across pumps which are only rotating as much as the oil is required based on servo. Now that's one kind of inspiration which has come from bio. So you don't keep running the pump all the time. You run it only on demand. Now that kind of optimization is also coming in engineering. And in engineering machines, you see applications. We see a lot of things like boiling, heat boilers, and refrigeration systems, which involve a lot of excessive heating and cooling. In biology, all the processes happen at the body temperature, which is only marginally higher than room temperature. Okay, nowhere near boiling point of water, well below that. Yeah, so it is to that extent energy efficient because any heating and cooling it adds to global warming eventually. Okay, so first sin is to create excess heat. Second sin is to, in order to cool it, create more heat by the refrigeration system, and then through radiator throw it in the environment. Basically, you are only pumping heat from somewhere into environment. Okay. So uh, now, how engineers have got inspired from some of these concepts is in two wheelers. If you consider, we used to have the brake wire, clutch wire, accelerator wire, which is somewhat like muscle fiber. The only difference is it is not contractile. It does not change in length by itself. It's only more of a transmission media. It's not an actuation device by itself. Okay. Those levers you have to press by hand. Actually, it's not self-actuated. Yeah. So it is more of a transmission. Okay. But nevertheless, it has been inspired. All right. And robots, one can imagine, we have seen robots which are like linkages, with the length of linkages remaining fixed. Now, if you assume that each of the linkage is something like a muscle or something like maybe a hydraulic or pneumatic cylinder, where the length of linkages also is variable. Okay. In robotics, it will give you a very big advantage in terms of reaching anywhere fast and increasing the reach of the robot. Yeah. So robo is a variable with variable linkage lengths, just like cranes are. Yeah. Will give a big scope for innovating to improve the performance of robotics. Possibility of using in biology, we in some video we have talked about flagella and cilia, where there are tiny molecular gears or rack and pinion kind of mechanisms which one come across, which run on cell membrane. Yeah. Now, inspired on those things in engineering, some research is being going on creating nano gears and creating nano walk, nano linear movement through piezo crystal. Okay, I will show you that. This is the piezo walk. Now these things are piezo crystals, which you see below these pods. Now, when you apply electric field to the crystal, the shape of crystal changes. Okay. Now you can go on changing the shape of the crystal and create a tiny micron level walk. Okay. Now this is something which is closer to molecular level actuation mechanisms which we come across in biology, which we have discussed in some of our previous talks. Yeah. Also, we can have nano gears. These are molecular level gears, tiny gears, which have been developed. These are some pictures from public domain. Yeah. Some kind of complex gear train based on molecular level, micron level. So some things are being done based on the ideas that we have come across in biology. The next big idea is the evolving software that we have in biology. Our software has been evolving. The kind of coding and archiving efficiency that is there in genetics and the growth, the conversion into actual life form is harnessing a lot of growth dynamics as we have seen in our previous video. So in engineering side, can use similar concepts where of course, software has been evolving, all right. Coding efficiency and archiving efficiency and harnessing the growth dynamics, something like that could be taken as inspiration. So, in engineering, mostly whatever CAD models or finite element analysis we do, we have tendency to pixel the whole object and pick up all the million points on the surface or through the solid, or we do FEMing, finite elements, break it into finite elements, and then we try to store humongous data, and we do extensive mathematical compute based software operations to do transformations, etc. And whereas in biology, the designs are stored as an incremental recipe, as we have seen in the previous talk, and the coding space shapes based on the protein kind of modeling. Now this is a new idea that the interspaces of the cell get codified by protein hardware. They get reverse transcripted, reverse translated, and get stored on DNA. Yeah, something like this concept can be inspired for engineering as well. So you have some room, for example, or you have some shape of a cavity. Now you have something like a protein molecule, which or a laser maybe, which can bounce off the surfaces multiple with multiple reflections, and then you encode the geometry. You straighten the beam, and you encode the geometry, something like what proteins would do, and store that data instead of trying to pixelize the whole thing and store all million points to represent the shape. Yeah, and that's an idea, can be carried forward. In engineering, we of course know to save the memory and processing, we do use what is called as parametric programming, where there is a software which presents you a screen. You just fill in some parameters and generates the program for your specific application. Yeah. Now, parametric programming is something like a template programming where you enter the dimensions and you get the program for the application that you have for the object that you want to represent. Yeah. So it is somewhat similar to physiological chemical messengers, which control the specs and growth and scaling of the body. So to some extent, parametric programming can be called to be somewhat similar to this. Okay, like hormones deciding the length of the bones, for example. Yeah. So there is some similarity there. To some extent, software versions that are there, multiple versions of software keep coming, and they are already being debugged, customized, refined, and they have evolved adaptively according to the changing application requirements and the bugs which we come across. So it is kind of self-learning, self-refining, self-evolving model of working that we already see in software industry. And in one of our videos, we talked about the growth dynamics, defining the interconnections of neurons in the brains and the migration of neuron into the brain creates a dynamics and creates interconnections, and that defines the specific expertise role of the neuron, particular neuron clusters. Yeah. So in industries, of course, this is more philosophical. In HR, they have the concept of giving job rotation to incumbent, where the person is moved through the organization to develop competence, networking, connectivity, familiarity, so that the person gets specific competence and expertise going further to fit into the role for which the person was earmarked. So though the person may not realize that, but then this idea is already followed by HR. Okay, when I joined the organization new, I always used to wonder why they have a tendency to throw us somewhere where we do not want to go. Now later it became clear that there was a thought process that we have to have connectivity and exposure to different domains before you go in the final seat that you are. Okay. Then what engineers can learn and explore is this is another great idea. In macromolecules which we come across in biology or in polymer science, there are stereospecific polymers where the shape of macromolecule is particular specifically made in space. Okay. Whereas in engineering, we are still struggling with the challenges of formability of metals, for example, due to the grain boundaries rubbing each other and getting interlocked. Yeah. So in organic macromolecules or polymers, they have been able to achieve stereospecific structure in space, where certain specific bonds of carbon get oriented at in certain angles, certain preferred angle. So thus they get a precisely defined structure in space as a space frame. Even as at each carbon there are possibility for the same bond getting oriented at any of the three angles of the tetrahedron. Okay. So the next atom can go at any of the three vertices of tetrahedron. But somehow chemists are able to control that, and it goes to one particular vertex only, so that the shape of the molecule is as defined in structure and it is consistent. Yeah. So on one hand, they are able to control the structure of molecule at molecular level in space. But in engineering, in metallurgy, the sheet formability and strength comes from randomly oriented grain boundaries. So they are not molecule, they are not even crystal, they are cluster of crystals forming grains, clinkers. And the surfaces of those grains, they get interlocked. And then there is a famous Hall patch formula, which tells you how much strength it will have, how much ductility it will have. Now, if only engineers could find a way to control and tailor the grain boundaries so that all those clinkers, their boundaries get aligned in certain way, well defined way, then you are able to tailor the ductility and strength of the material, and you can vastly improve the metallurgy formability of the material. Yeah. It may even become possible to grow a single metal crystal instead of having clinkers and cluster of grains. Yeah. If a single, see, when do you get maximum strength and maximum ductility? When you have a single big crystal. Assume that an object is a single crystal. A sheet is made up of a single crystal. Suppose, for argument's sake, you are able to have a crystal, face centered, body centered, or whatever crystal lattice we have, but entire thing is a single crystal. Then it will give you almost infinite ductility and highest possible strength, because the crystal bond is the strongest that the metal can get. Yeah. So one can really get superlative strength and superlative ductility, which is what is desirable for engineers who work on sheet formability and want to make the car bodies and aircraft bodies, stuff like that. Next idea is, of course, addressed to artificial intelligence. So, in neurons, we discussed in our talk also on the subject that in biological neuron, when the neuron fires, which input have made it to fire, that trail is not being lost. Okay. But the software neurons that we use for AI, for deep learning, so neurons are merely doing weighted summation of all inputs, and they are checking the gross threshold. So either it fires or it does not fire. But if it fires, you don't know what has caused it to fire, which input has caused it to fire, from where it has come. So we are losing the trail of from where the signal is coming. That's a big information getting lost. Okay. So lot of traceability of information is getting lost, and it's more or less working as a combinational logic. We are not talking of propagation delay from the point where the input is coming up to the point where the output is coming. We are not considering the ionic tree within the neuron. And so in biological neuron, all that happens There is a sequence factor, there is a time factor, there's a propagation delay, and the trail is not getting lost. When a neuron fire, the system knows from where what has caused it to fire. Yeah. So that information is not being lost. So in AI, the way we are doing it, the learning is only happening by way of tweaking the weightages to different inputs, but all inputs are same. They are treated as same. In biological neuron, learning is based on morphology. It is based on physical connectivity, physical growth of ionic channels, and consequently, the complex ionic tree trail is traceable along with finer aspects of propagation. So, this is something for AI people to consider, the researchers in AI. And another big debate happens with artificial intelligence people, that AI people, the initial their agenda was to replicate a human brain like system in computer, which will be working like human brain. But if you invest say millions of dollars and do make a system which work like human brain, it will also have the unpredictability, moodiness, temperamental nature as human brain. So sometimes it will work, sometimes it will not work. Do we want that? So, so the advice is, do not make AI to carry the human vagaries and human variability. So there is a new movement in industry called Industry 5.0, beyond Industry 4.0, which was everything talking to each other through internet, through connectivity. Industry 5 is not so much about automation, it is about automation with human face. So human being and machines are working together. They are supposed to complement each other the way they have, the inorganic things have complemented our physical attributes. So in Industry 5, we want machines to adapt to human vagaries, and human will work like human. They will have their vagaries, they will have their creativity, they will have their moodiness, but machines will work consistently without getting tired. Okay. So let machines be machines, let men be men. That's the advice. Let's not mix the two. The last idea that engineers can learn from me, of course, there are many more ideas, but I have just decided to focus on 6 ideas today. So, advanced technologies of medical imaging and respect of the expertise. Now, you see, in medical field, there is a lot of respect and value for expertise. It's way better than what engineers get. Because in engineering side, in industries, technocrats get overwhelmed by the people who are in financial and management side, and they get bullied and they get subdued. Yeah. In medical side, expertise is indeed respected. There is a premium for expertise. Now, engineers have to also find this thing in their domain if they want to improve technology. So, and also another point of comparison is that in medical side, we see extensive use of say medical imaging and diagnostic and surgical aids which use high tech. The kind of tech savvy devices they have in medical side, engineering is nowhere near that. Still we are dragging our feet on technology. So I remember many years back, we used to have something called as engineer stethoscope, but even that did not become very popular. In engineering, we do use a little bit of ultrasound through probes, but it is nowhere near ultrasound imaging the way we see in medical. And there is nothing quite like CAT scan and PAT scan. At best, we have only optical digitization of surfaces, which is way behind what medicos are using. So I urge engineers to open themselves to technology, to high tech, and try to take a leaf from medical side and implement all these advanced technologies in engineering. Now we come to the other side. So I will not say that these are things that they should innovate. I will not use that term for medicos. Uh, these are just some unusual ideas which I am presenting for them to think about it. if possible, to research on these and carry them forward if you like them. Okay. So take it or leave it, but these are the ideas that you can think, at least consider. So one thing which is there in engineering and not so much there in medical side is the extensive use of software simulation and CAD models, etc. So with synergy and cross fertilization of concept from human anatomy, physiology, and computers, now we have immense possibilities of simulating the behavior of whole human body on computer. And this could be done at many levels for different varying requirements. So what are the different ways of and different levels? So level 0 is, I would say, that it is attributes focus limited simulation, that we just want to say predict the drug dispersion, which I'm sure pharmakinesis people are doing, and the side effect of medicines administered virtually. Suppose you take certain dose, what happens after what time, etc. So gross parameter level simulation based on empirical data, building predictability through software, say predicting immunological responses. For example, there is certain virus attack or bacteria attack, what is going to happen after what time. Okay. Gross physiological parameters such as blood sugar, urea, creatinine, hormone level, based on empirical data again. If you eat something, what is going to happen to blood sugar? You could have those software models to see, and even virtual pathology one could do based on prediction. Now, the next level is a little more intense, that in the sense that you pixelize the body, you take the tomography of the body, different cross sections at different layer, okay, and record each pixel, hmm, along with some attributes, that what is the color of the tissue, for example, what is the appearance, okay. So, and you assemble it and you have a virtual, I would say, model of the human body, where somebody can take any cross section. You could do virtual dissection also, for example, for teaching. Instead of physical detection and dissection, you could have virtual dissection on computer, and you know that if you cut here, what do you see? What is the size of bone at different places? What is the size? What is the cross section at different places? So basically, a total point cloud based model of the human body, human anatomy, and where it is, of course, a static 3D model. The body is not moving, it is not breathing, it not blood is not flowing, it is just frozen. But you take a cross section, you know how the cross section looks like. Okay, so mostly it is for the purpose of visualization and virtual dissection, where certain tissues you can switch them on or off. So it's like a dissection kind of a thing. Okay, so you want to see behind the lungs, you can take out the lungs and see how it will look like something like that. Yeah. So that's another level, that graphics based simulation of the human body. The next level is to this level 1. You add also the properties of various tissues, such as the stiffness, hardness, elasticity, fluidity, porosity of bone, for example, dryness, wettability, and viscosity, if you please. Yeah. So you can assign these attributes to each pixel. It's not only showing that color as a graphic, it is also having a feel, touch and feel. So to elevate the application level to practicing virtual surgical procedure with touch and feel of the process through surgical tools. And you could have transducers, you could use AR, VR, etc. by all means. So you could do virtual surgery with the touch and feel. That's the next level. The third level is body is not static, things are flowing, limbs could be moving, person could be breathing, blood could be flowing. So add all the dynamics of blood flow, food movement, respiration, heartbeat, squeeze applied on glands, and force on the muscle lined vessels. So in third level, you can add all this and you can have a model which represent all these things of human body. And level 4 is specialization based simulation suite. I mean, not all the doctors do everything. So there are heart specialists, there are kidney specialists, there are liver surgeons, there are G&O, there are pediatricians, eye surgeons, ENT. So you could have further specialized simulation suites focusing on specializations, super specializations. That would be level 4. And level 5 is addition of oncology and growth dynamics, uh, refer to our previous video showing the growth dynamics, etc. We can have the software model showing the growth dynamics, where you can take any tomographic section and see how it will change every day, every week. Yeah. So how does the growth take place? How do tumors grow? How do cancers grow? How they will spread? All this also could be simulated on software. Okay. So great idea. I'm not sure some of these softwares may already be there, but I have not seen, at least I have not come across on internet. So yes, these ideas are there. They are already there. So far, so good. Simulation of neural behavior, working of brain. This we talked in our some videos on neurology, where we can simulate the input output conditions of neurons, how the reflexes should work, how the neuron will learn, how the action potentials will flow, what will be the neural currents, what will be the brain waves, for example. And also, in our second last talk, we talked about the effect of foods and effect of medications, etc. So homeopathy, acupuncture, how it would work through neural interconnection. Okay. So there can be a computer simulation model which can help the specialists in honing their expertise and giving them ideas and in virtually seeing what will happen if something happens. So simulation of human body is a very big revolution waiting to happen, mainly for want of interdisciplinary competences spanning across software engineering and bio. And this series is a small attempt in that direction to promote some interdisciplinary thinking at least. Okay, the next idea, unusual idea for medicals, is we talked about materia medica and homeopathy and acupuncture and acupressure, etc. The therapy is based on neural interconnectivity and intelligence. So we could have IT based interactive and self evolving materia medica. Why we can't have a reference book on online? Okay. And we could have a portal where somebody can assess himself. He can fill in the form or have an interactive session. And the system identifies his brain class and the symptoms, and based on that, the system suggests the repertory, the medicines, and you can say that yes, I have already tried this I have not tried, and like that, you can have a self treatment. Yeah. So materia medica may be made available online in interactive mode for self diagnosis and for selection of medicine and dosage. Empirical database on which it is based also could be dynamically updated. Now, all these things which are based on past empirical data, the empirical data is frozen. Okay, historically, many years back, many decades back. Now, as we say that the rate of change is going up, so what worked then may not work now, and surely there is a need to keep the empirical database updated. Now, if it is interconnected on a portal, if different practitioners enter their observations and they go on updating that empirical database, it will be a dynamic database, not be a static database. Okay. So that's what one would expect going further, that all the database based on which you are deciding everything should be dynamic. It should not be static. It should be evolving also. So what will make it to evolve otherwise? And also, talking of homeopathy, we get a medicine and some potency is written on that. We don't know. We can't verify if it is that or otherwise. Unless, if suppose level goes off, we can't identify what is the medicine and what is the potency. So there could be some instruments to measure the potency of a sample of a medicine. It's an instrumentation challenge. You can find out how many replicas have been are floating in the medicine. What is the density of those, and what are those replicas? What do they? What kind of poison do they represent? Yeah, that's an idea. Yes. Otherwise, everything we are depending on the discipline followed in pharma. Any changes reported by the patient also should be recorded. Suppose he takes a medicine and he feels that he has a side effect or a reaction. Presently, they don't recognize that there is a side effect. They say it doesn't happen in our therapy. No, there is no such thing. At least record. At least record it on some portal, and later you may have some database to guide you what kind of reaction will happen if the medicine indeed works. If the medicine doesn't work, probably you will have no side effect. But if it works, surely there could be. Because if there is an action, there will be reaction, certainly. And if there is no reaction, apparently there is no action either. So that is something to be carried forward. Then extensive use of devices like mind mirror and biofeedback. You can sense the brain wave non-contact way. Okay. So brain waves could be measured in a non-contact way, and you can present some kind of bar graph on some computer screens or some displays. Suppose you have a brain wave meter or a mind mirror, so called, behind the seat of the boss sitting in his cabin. Anybody entering in his cabin will know what is his mood. Okay. So is he irritable? Is he in a good mood? Is he in a mood to listen? Will he have a tendency to shout, or will he have tendency to empathize? Can he concentrate at this point in time? Can he decide, and can he be receptive to innovative ideas, or can he produce innovative ideas himself? Will be a great aid to decide when to talk to such people, when to talk to experts, when to talk to bosses, when to talk to decision makers. Yeah, so there is a big practical utility. Also, biofeedback is of course biological parameters, so that can give some indication of what kind of frame of mind the person is likely to have. There is a practice in sales and marketing that they use NLP, that is called as neuro linguistic programming techniques. And based on eye movement, the salespeople are trained to identify the customer's type, whether the person is thinking visually, whether the person is thinking through sound, whether the person is sensual and thinking through touch. So, suppose some salesperson is showing a car, okay. If inherently the person thinks through sound, the salesperson will start the car, will focus on the music system to attract the attention of the particular customer and to make him to like the offering. If it is on visual system, maybe he will focus on lighting of the car in that room. He will turn on the headlight, turn on the inside lights, and show the colors and show the textures. If the person is touch sensitive, then it is the focus is on touch. So all these NLP techniques one can augment with all these mind mirror and biofeedback. Okay. So if you have some device which is there on the wall and which can remotely monitor the people who are coming through the door, or people who are seeing the particular model of the car. Okay. The salesperson can get a cue of how to talk to them, what to talk to them. Similarly, even car is a big thing. Suppose you are in a sari center and you are selling the saris to ladies. Which color they are liking, which they are not liking, are they liking bold prints or fine prints? So it will give them important clue to the person who's attending to the customer. Yeah. So there are applications of these concepts. Okay. So people can be trained to these and then they know uh, what would be liked by people. So what is to be shown to people. And this is something that Industry 5 is also envisaging, that in Industry 5, human is supposed to work with robots together. Now, we don't want robo to take out saris and show it to the client because robo cannot do things like NLP analysis. So, whether the person is liking the thing being shown or not is the best decided by human. But yes, to fold the saris which have been tried can be robo's job, and to keep them back in where they were. Yeah, that's the kind of cooperative working which is envisaged in Industry 5. Yeah. So biofeedback devices could be used to aid the treatment through diet, through regimen, through acupuncture, through acupressure, through massages and oil bath. All the neural related therapies can be based on biofeedback. The next idea is many times engineers feel, I mean, we may be wrong certainly by all means, but feel that heart is just a pump. Intelligence wise, if you see, what is the intelligence level of a heart or a kidney? Kidney is just a filter, heart is just a pump. Simple mechanical devices doing simple function. So why is it so difficult to make them synthetically, and they could be worn externally also? Okay, so that's an line of thought which can be pursued. I have not included liver in that because liver is complicated, brain is complicated, but heart, heart and lung machine, we know it has been there. From intelligence and functionality point of view, so heart is only a pump and kidney is only a two-stage band pass filter. So first membrane allows particle below certain size to come out on the other side, and then there is a second membrane which pumps in particles smaller than certain size back, so that it's a band pass filter. The particles between certain size bands get excreted. Okay. Otherwise, all the water will get drained for sure. So, so that is the kidney. But can't we build a band pass filter? We can certainly. So I would think going further that it should be possible, very much possible, to build artificial heart machine, heart lung machine, kidney machine, which could be presented as a wearable for the patients. And these are some things which, I mean, okay, it doesn't affect the intelligence. So technically, may not be a big deal to have these functionalities through externally worn devices, which could be commanded, of course, like there can be some things commanded neurally. Now you can have those interfacing done to these devices as well. Like you want to increase the heartbeat rate based on certain parameters. Yes, you could still do that to the external heart also, right? So we do have a heart lung machine, which is and a dialysis to some extent, but yet they are nowhere near being a regular wearable kind of thing, like pacemaker, for example. They are nowhere near that. So going further, yes, that's an idea which could be carried forward. So next idea is externally acting immunological functions. Why we can't take the immunology outside our body? You identify the viruses outside our body and kill them outside our body, instead of viruses coming inside and then getting identified by our immune system. And then we can have something like antivirus, external antivirus. So just as in homeopathy there is mother tincture and water, and they print the counter shapes from the molecule from poisons and replicate negative profiles to identify the poisons. We could use the similar technology to identify the viruses. and you can spray something which will neutralize those viruses, some antivirus will generate counter shapes, and you throw them at the virus, and the virus, those shapes will get neutralized, which act as key to enter in the cells. Okay, so viruses can get neutralized, they can be made dysfunctional externally through something like meshes in the air filters, for example, in cars and aeroplanes and rooms in AC systems. Yeah, now that's an idea. I come across that in IIT people did try to make something like this for COVID, but I'm not sure what has happened to that thereafter. But this is an idea which can be carried forward further like that. And last idea is the biggest problem is for cancers. If I talk, the biggest hurdle in treating cancer is that genetic learning, unlearning, and refinement take several generations. So, if there is a corruption in genetic code, after several generations of cell, only the system can realize and correct itself and get rid of that basic problem. Now, if it were somehow possible to accelerate the genetic learning faster so that improvement happens within the lifetime of cell instead of cell dying and some change will only happen in the daughter cells and their daughter cells that after. So, if we could have some tailored mutations by a specific designer vector. So we just like virus, we can have some benign virus which could carry some vectors which will have some designer mutations to neutralize the things which cause cancer. Okay. Probably it could give us a handle on nipping cancer. Okay. So that's the last idea. Far fetched at the moment, yes, but it's an idea, all right, to be considered. So thanks for your interest, not just in this video, but in all the series that is there. And bye bye, all the best. I am sure you have found the entire series interesting. If not, request you to watch it again, request you to like it, and request you to do word of mouth publicity for this. Bye bye.